Hello and welcome to another WorkSource Spokane training module. This is the beginning of our AI series, AI 101. And in this module, we're just going to do a brief introduction to what AI is. Now, here's a brief little agenda of what we're going to be discussing during this module, AI 101. We're going to start off with an introduction to AI, what AI is, and a couple of the myths surrounding AI. We're also going to talk about machine learning. We're not going to go too deep into that. This isn't a computer science course, but we do want to understand how AI is created and what goes into that. And with that, we're going to discuss just a little bit about neural networks. And then I'm going to give you an overview of some of the different AI models that exist out there. Then we'll follow up with a conclusion and talk about some next steps as you go through this AI course. Now, when you hear me use the term AI, what I'm referring to is artificial intelligence. And from here on out, I'm just going to refer to this as AI generically. Artificial intelligence is the term we give to computer systems that can perform tasks that usually require some kind of human input or human intelligence. They're not actual sentient programs. They are just programs that can perform tasks kind of the same way we as humans do. Now, this could include things like problem solving or learning certain complex things, understanding how to process natural language like the way I'm speaking right now, recognizing patterns, which is an important part of understanding natural language and things like that. We can even use AI for making certain decisions, although we may not want to do that too much. Now, AI as a entity in and of itself can be found in a lot of different applications. Chances are you use AI yourself on a regular basis. Virtual assistants like Alexa or Siri or Google Assistant incorporate forms of AI, and we're going to talk about a little bit like that. But then we can also go even further beyond all of this and talk about things like self-driving cars and some of the advanced data analytics software that exists out there. As we explore more of what AI is capable of, we're going to see that the world is going to adapt and change to grow along with that. And we've already seen that. We've seen how AI has transformed industries, how it's increased efficiency in certain arenas, and how it's opened up new possibilities. Now, to help us truly understand the impact of AI and how it's affected our world, we do need to do just a brief little history lesson. Now, uh, you've probably heard of somebody named Alan Turing. You may not be intimately familiar with him, but if you ever want to learn more about Alan Turing, I would recommend a movie called The Imitation Game. Benedict Cumberbatch, I'm a kind of big fan of Benedict Cumberbatch, even in his BBC days, before he did Doctor Strange. He did a movie about Alan Turing. Alan Turing was a British inventor back in the World War II era, and he is widely considered to be the inventor of the computer. And by extension, he is kind of the godfather of AI. Now, the whole reason we want to talk about Alan Turing is because of something called the Turing test. The Turing test is kind of a thought experiment process that is used in computer science to kind of determine who the humans are versus who the computer programs are. If you've ever encountered something like CAPTCHA, that's a Turing test. It's actually part of the name. Now, we fast forward just a little bit further, and we get past the World War II era. We start to get to 1956. This is where we get to the Dartmouth Conference, and that is where the actual term artificial intelligence was first coined. Before 1956, artificial intelligence had been kind of hinted at in science fiction and things like that. And if you've taken some of my other digital literacy modules, we've talked about science fiction turning into science fact. Well, 1956 and the Dartmouth Conference was one of those kind of big important points. As we move further, research started going into computers and what computers were capable of, and writing the different programs that go into that, the software that those computers run on. And this is where you spawn a whole bunch of different things in science fiction. We see this a lot throughout the 50s all the way up through the 80s with movies like, say, War Games. If you remember that one, I want to say that was Matthew Broderick. Would you like to play a game? I'd like to play a game of chess or something like that. And then we start getting into the 60s and 70s, and we start seeing some of the very, very early AI programs start to come out. Now, these were not actual AI programs. Most of these were just simple programs of if-then statements where, if this condition is met, then start doing this, whatever that might be. And we started seeing things like ELIZA, which was one of the first natural language processing programs, or Shaky, which was an actual robot that was capable of problem solving. And then we fast forward even further into the 1980s, and that's when we start getting into things like expert systems, where we built very, very large computer models for analyzing complex problems and really kind of helping humans decide things in very specific arenas. Then we get to 1997, and this is where the idea of AI in modern computing really started to take off. And there was a company, you may have heard of them, IBM, that created Deep Blue. Now, IBM's Deep Blue was supposed to be one of the earliest supercomputer AIs that was capable of beating a grandmaster at chess. Deep Blue was very famous for being a chess-playing computer, and in 1997, Deep Blue finally beat Garry Kasparov, which was one of the chess grandmasters of the time. Now we fast forward to the 2010s. And this is where we start getting into machine learning and deep learning. Now we no longer have just very complex computer programs that understand inputs and outputs. Now we have computer programs that can essentially think for themselves. More in the sense of they're able to draw their own conclusions from particular data sets. And that's what we're going to be talking about as we get into some of our later slides, is what machine learning is and why it's so important in the realm of AI. Now, here we are, and at the time of this recording, it's still the year 2024, at least for the next 12 hours or so. But as we are sitting here in the mid-2020s, let's talk about how AI has affected us in our daily lives. And I mentioned this just a little while ago. Chances are you use AI on a daily basis without even realizing it. And one of the first ways that we interact with AI on a regular basis is something that I just mentioned a little while ago, and that's our virtual assistants. We have programs like Siri and Alexa and Google Assistant, or if you want to get a little bit older with it, you might have used something like Cortana. Cortana was integrated in the Microsoft systems and now is the evolution that we call now Copilot. We're going to talk a little bit about that a little bit later on. Virtual assistants have been using AI algorithms for almost a decade. It's how they are able to interpret our human speech into actual commands that they will then act upon. And we'll talk a little bit about how queries were kind of come about as we get into AI 102 and prompt engineering. We're not going to talk about that here just yet. I just want to focus on the different ways that AI is integrated into our daily lives. Virtual assistants like Siri and Alexa are a prime example of that. As we get a little bit further into some of our daily computer experiences, we might encounter recommender systems. Now, a recommender system isn't something that most people really refer to these things as. More often than not, it's just something that you experience. Now, if you've ever used an application like Netflix or Amazon Prime or Hulu, you may encounter a section in those applications where they recommend new shows or new movies or new products for you. A lot of the ways that these applications recommend things for you and personalize and tailor them to your unique experiences is by using AI algorithms. Now, another way that we see AI being used is for things like navigation and maps. Applications like Google Maps or Waze will use AI algorithms to help create some of those navigation paths. There's a car accident up ahead, so it's going to reroute you around that car accident, or there's a lot of congestion at this particular intersection, it's going to reroute you around that intersection. Well, these programs are now using AI algorithms to help them generate those new pathways or generate those new routes, if you will. We might see our smart home devices use AI a lot more heavily. Now, I use a lot of Google Home devices in my personal life. And if you've taken some of the digital literacy modules, you probably know I do a lot with the Google ecosystem in my personal and private life. Well, a lot of my Google smart home devices now incorporated different AIs. And just like we talked about, that's just an extension from the Alexa and the Siri and the Google Assistant that we talked about before. If you are utilizing certain websites and you have to get a hold of customer service, a lot of company websites will utilize a kind of live chat feature. If you go to worksourcewa.com, you'll see a live chat feature on the worksourcewa.com website. Well, our worksourcewa.com live chat is actually powered by actual humans on the other side. But some companies are now utilizing AI chatbots to power that live chat function on their websites directly. So you may think that you're talking to a customer service representative, but you may actually be just chatting with a computer program, an AI-powered computer program. We also see AI being used in e-commerce personalization, and that kind of goes back into those recommender systems that I was talking about a little bit earlier. If you go on Amazon Prime or eBay or Etsy, and you might see that they've recommended particular products for you. You might get an email recommending particular products, or you might get a notification on your phone recommending particular products. A lot of those recommendations are coming from an AI program that has analyzed your purchase history and the different products that you may have browsed or searched for, and then it will generate a series of recommendations for you specifically based on your particular tastes, wants, and needs. You might see AI being used in social media. If you use programs like Facebook or Instagram or TikTok. I'm not a big fan of TikTok, but I know it exists. A lot of times as you're scrolling through your feed, you start seeing videos from people you've never interacted with. You start seeing posts from people that you've never actually talked to or interacted with in real life. And that's because the algorithm is actually recommending those people for you. Those are powered by AI. They're using AI algorithms to help generate some of those responses. So let's talk about a couple of AI myths. And this is not an unusual thing for me to encounter. I encounter a lot of people that may have some misconceptions about what AI is and what AI is capable of. So I have a couple of things listed here that I just want to impress upon you as far as what AI is and isn't capable of. First things first, AI will not replace human jobs. That is a complete myth. There is this pervasive mentality that has been around for decades that the robots are going to replace us as workers. That's not going to happen. AI is not going to replace human jobs, at least not all of them. Now, there are a lot of jobs and industries that are going to change because of AI. AI is going to create new job opportunities and transform a lot of the existing ones that already are out there. But all AI is going to do is just augment the capabilities of what humans can already do. One of the tongue-in-cheek phrases that Sam, my counterpart, and I like to throw at each other: AI isn't going to take your job. Somebody who knows how to use AI will. And that's the thing we want to focus on. Now, another myth that comes out about AI is that AI can think and feel like humans do. That's not true. They are computer programs, and at the end of the day, they are still just computer programs. They are just bits, ones and zeros that exist inside of a computer. They do not have the same thoughts or feelings that we as humans do. So when they generate things like a picture or song lyrics or whatever the case might be, a lot of times they're going to be lacking the depth and emotion that we as humans can create. Now, it will mimic human behavior, but it's going to lack the consciousness behind it. Another myth that we see when we look at AI is that AI is infallible and completely unbiased. No, that's not completely true either, because a lot of AIs are built upon trained data sets. They are trained using data sets that already exist, and a lot of those data sets are going to be created by humans. So by nature of humans training the AI is naturally going to have a small amount of bias. Now, that bias is a lot lessened through AI, but it's not completely gone. And just because AI said something doesn't mean it's true. Just like we used to say back in the early days of the internet, just because you found it on the internet doesn't mean it's true. Well, the same is true with this myth. Just because AI said it doesn't mean it's true. And you may hear us talk about things like human intervention. This is where that human intervention piece comes into play. As the humans that are reading the responses that AI generates, it's our responsibility to make sure that we are double checking what AI gives us. Another myth that we see about AI is only for large corporations that have the money to be able to power it. AI is only for the tech experts that know the differences between machine learning and deep learning and supervised. That's not completely true either. I use AI on a regular basis, and while I am the digital literacy instructor, I am by no means a tech expert. I am not a master at any of this. And I work for a nonprofit. I don't work for a large corporation. But I use AI on almost a daily basis. And I use AI for a vast number of different things. And you're going to see some of those examples in some of our later modules. The final myth that we see here is that AI will eventually take over the world. And of course, we've all watched the Terminator movies. We know that Skynet exists and Skynet's going to take over the world eventually. Well, that's not necessarily true either. As long as computers have been around, as long as computer algorithms have been written and created, there have been people that have been constantly saying, hey, we need to regulate this so that way this doesn't replace humans. This doesn't replace our human society. This doesn't take over the world. And with all of the expansion that we've done in the last few years with GPT and AI, there's been a lot of government regulation and a lot of societal regulation as well. Researchers have put things in place to make sure that AI is being used ethically and responsibly. Now, to help us understand how AI is different than, say, a regular old computer program, we need to talk a little bit about machine learning. Now, machine learning, as a definition, machine learning is a subset of artificial intelligence that involves the development of algorithms and statistical models enabling computers to learn from and make predictions based on data. What does that actually mean? Well, that means that rather than AI being a computer program that is programmed to perform specific tasks in a specific order, machine learning systems use patterns and data sets that have patterns that are already pre-described, data sets that have patterns but aren't pre-described, and things like reinforcement learning to help those programs create their own processes, create their own procedures, and kind of infer how to improve themselves over time. Now, this process usually involves training a model with a very large data set, and then helping that model kind of identify the patterns within that data set and help it make its own conclusions based on the relationships within that data. So that way, when that model, that AI model, is presented with something new or something unknown, it can kind of use some of that experience that it's already gained from machine learning to determine what the next result might be. Now, there are three big pieces of machine learning that we want to talk about. There's a lot of other details that go into it, but there's three big ones that we want to touch on here in this module. And that's supervised machine learning, unsupervised learning, and reinforcement learning. Now, the first form of machine learning that we want to talk about is supervised learning. And this is the type of machine learning that involves training a model based on a labeled data set, meaning that every single piece of data, every single piece of input that goes into this model is already predefined as far as what it might be and what the appropriate output label is supposed to be. Now, as you are feeding this labeled data set into the model is learning how to basically make the association between what the input is and what the output should be. This is very, very common for things like classification or different kinds of regression models. The example that we have here on the slide really helps us kind of showcase this. If I were to have a model that I am training, a computer program that I am training, and I want it to identify shapes for me, I might feed that model a giant data set of different shapes. Hexagons, squares, triangles. I'm going to give it every single type of triangle that exists. I'm going to show it every single kind of square that I can think of. I'm going to show it every different kind of hexagon that I can find. And then as I'm feeding it all those different pictures of all those different shapes, I'm going to make sure that I tell the model with each and every single one of those shapes what kind of shape it is. And the idea is, if I feed that model all these different shapes and I tell it what all those shapes are, that machine will then learn what a hexagon looks like, what a triangle looks like. And eventually that model is going to kind of create the pattern. It's going to start to recognize the pattern. Oh, this is a triangle. I know it's a triangle because it has three sides. How do I know that it's a triangle with three sides? Because all the other triangles that you just showed me had three sides. And you told me that they were all triangles. So when you show me this other three-sided thing that has no label with it, I'm going to automatically know that it's a triangle. If you show me something with four sides, I'm going to look at my data set that says all these four-sided things are squares. So when you show me this other four-sided shape that has no label with it, I'm going to determine that it is a square. And the same is true with hexagons and other shapes. Now, this isn't going to be a perfect model because the machine may say, hey, this is a four-sided shape. It's a square. Well, actually, it's a rectangle because two of the sides are longer than the other two. So there's going to be some fallibility within all of this. And this is where we can get into some of our other types of machine learning. Now, our second type of machine learning is unsupervised learning. And this is basically the exact same thing as supervised learning, except instead of having a labeled data set that we feed into the AI model, we have an unlabeled data set that we feed into the AI model. Because it's unlabeled, it's unsupervised. Now, the goal with unsupervised machine learning is to force the algorithm, force the model to create its own patterns, to determine what those patterns might be without being explicitly told what those patterns might be. So a lot of times unsupervised learning is used for things like clustering or dimensionality reduction. Clustering, as an example, might be grouping customers of a large corporation into different clusters. We have some customers that are single purchase customers, and we have other customers that are multi-purchase customers. The machine doesn't know which one's which, so it's going to look at the entire set of data and make its own patterns and determinations based on maybe a purchase history or something like that. The example that you see here on our slide, we have fed our machine with a bunch of raw data of pictures of pets. We didn't tell the AI model what those pets were. We didn't tell them what species those pets were. We just fed it a whole bunch of pictures of different pets. And then the machine created its own pattern based on what it saw. Oh, it has two pointy ears and a tail. It must be a cat. Well, no, actually, it might be a dog. Oh, it has two pointy ears and a tail, and it has a particular shape of paws and a particular color. It might be a cat. Well, we're going to group these over here because they look similar, and then we're going to group these over here because they look different. That would be an example of machine learning using unsupervised learning. The machine doesn't actually know the difference between a cat and a dog. We haven't told it explicitly that these are cats and these are dogs, but it's using similar features in the data sets that it looks at to make those determinations by determining those patterns, recognizing those patterns. Now, as we look at supervised and unsupervised learning, we're going to get into a third and final part of machine learning. The final part of machine learning is what we call reinforcement learning. And to kind of boil this down to a simple phrase, this is literally learning from your mistakes. When we look at reinforcement learning, typically this is the type of learning where an agent or a model is interacting with a particular environment with the express intent and purpose of maximizing some kind of reward. A lot of reinforcement learning uses either rewards-based systems or points-based systems, and then the computer algorithm is essentially just going through the process to try to maximize the amount of points. Now, there may be other forms of feedback in terms of penalties, and as the reinforcement learning is more and more complex, you might see stuff like that occur. It's usually used for a lot of different scenarios where decision making is required. So a lot of your AI algorithms that might, say, play chess might use reinforcement learning. Oh, I'm not going to make this move because this move's going to lose the game for me. So I'm going to make this move instead. The very basic example we see here on the slide is a dog. Now, the dog in this particular situation is the agent. The environment that the dog is in is whatever room or house or whatever the dog might be in. Now, if I give that dog a command to sit, and that dog chooses not to sit, that dog is not going to get a reward. If I give the dog the command to sit, and it chooses to sit, then it gets a treat. And over time, that dog is going to just naturally learn that if I tell it to sit and it sits, it gets treats. Even my own cats at home, I've done this exact thing with. We have an older cat at home. He's about 15 years old. He has a different diet than the other two. And we have trained him that if he sits and he paws at our leg, we will feed him a little bit of kibble. Now he knows that as long as he paws at us, he gets kibble. If he doesn't paw at us and he just sits there staring at us and looks at us, he doesn't get anything. That is a type of reinforcement learning. And we use this exact same thing to train AI models on how to make good decisions. Now, as we go about talking about AI, and as you read and learn more about AI and what it is, you may hear the term neural networks be used. The term neural networks refers to a type of machine learning model that is basically inspired by the structure of the human brain and the way the human brain works. It usually consists of layers of nodes, and those nodes are essentially the neurons of the machine model. And those nodes transfer information from each other to each other. Each node will have a particular weight attached to it based on whether or not it's a better decision or not. And that weight is adjusted through training. This allows that model to learn and make predictions. Now, neural networks are very, very good at recognizing patterns and making very complex decisions, which is why they are a key technology behind a lot of the AI applications that we see in the world today. An example of how we see this is for things like image recognition. If you use Google Lens uses image recognition, and Google Lens utilizes neural networks and AI to help recognize what's actually in the picture that you take. If you use anything like your virtual assistants that we talked about earlier, Siri and Alexa and Google, if you are interacting with those virtual assistants verbally, those virtual assistants are going to use neural networks to help it process our human speech, our natural language. You might see AI used for speech recognition and for medical diagnoses. Now, this is not the same as WebMD. We're not talking about things like that. We're talking about programs that actual doctors use in hospitals for helping them determine things. Now, the final section that we're going to talk about here in this module is just an overview of some of the AI models that exist out there. Now, remember from the very beginning, AI models are sophisticated algorithms that are designed to perform tasks that typically require human intelligence, human ingenuity. These models are trained on very large data sets using the same machine learning methods that we just talked about. And a lot of times these AI models are designed to help generate new content. And this is really what makes AI different than a lot of the computer programs that we might talk about in regular computing. These AI models have the ability to predict, to generate, to create. Not quite the same as what human ingenuity might be able to come up with, but at least to a point to where we can get an idea off of them. And you're going to see that as a theme as we look at some of these different AI models. Now, I'm going to focus on two of the big ones here in this module, and then I might demonstrate some of the other ones that exist out there. Now, the very first AI model that I want to talk about is Copilot. Copilot is an AI model that was created by Microsoft, and by definition, Copilot is an advanced AI assistant developed by Microsoft designed to enhance productivity and provide intelligent assistance in various tasks. One of the big ways that Copilot is used is for content creation, content generation. And because it's made by Microsoft, it actually integrates with a lot of the Microsoft applications like Microsoft Word, Microsoft Excel, Microsoft PowerPoint. And because of its integration with Microsoft and Microsoft's data security policies and the things that it has involved, Copilot is the AI model that is used by the Employment Security Department. There is another AI model that exists out there that I would put on the same tier as Copilot, and we'll talk about that on the next slide. The second AI model that I want to talk about is Gemini. Gemini is very similar to Copilot, except Gemini was created by Google, whereas Copilot was created by Microsoft. Now, when we talk about Gemini, Gemini is a very advanced AI system that was created by Google DeepMind. And it is designed to kind of push the boundaries of what AI is capable of. Now, one of the things that makes Gemini a little bit different from Copilot is Gemini has access to the entirety of Google and the powerhouse of the Google ecosystem. So it's going to be a little bit better for some tasks rather than content creation. It's going to be a little bit more for the analytical side of things and the research side of things. Now, Copilot and Gemini are the two AI models that I'm going to focus on here in these modules, but keep in mind that these are not the only AI models that exist. And even at the time of this recording, I haven't even explored half of the AI models that exist out there. And chances are by the time I get this finished, there's going to be new AI models that are already created. There's new ones that I've added to this list just in the time of writing these modules. So as we go about our daily lives, as you go about your computer journey, just keep in mind that this is not an end-all be-all list. There are many AI models that exist out there, and some of the ones that we see here on this list are going to be geared and engineered towards very specific purposes. The very first one we see here on the list is Suno. Suno AI is what is used for content creation. You can use Suno AI for creating music. You might use DALL-E 3 for image generation, ChatGPT for text generation. There's other AI models like Claude, Perplexity, and Deep AI, not ones that I've messed around with myself. Midjourney is good for image generation. Leonardo, image generation. Sora is good for video generation. Backflip is one that I literally just learned about just this morning, and it's used for 3D object generation. If you've taken my 3D printing module, you know how hard it can be to generate a three-dimensional object using CAD. Well, now we have AI programs that can literally do it for us. So as we go about our computer journeys and as we go forward into the future, just be prepared for a lot of these AI tools to come out to help us perform some of these more creative tasks. Now, just to summarize what we've talked about in this short module, we started out by talking about what AI is. I gave you a brief introduction to AI, some of the history behind it, and some of those myths that we've kind of encountered about AI. As we got deeper into what AI is, we talked about the different kinds of machine learning. Keep in mind that those three big pieces of machine learning, we have supervised machine learning, unsupervised machine learning, and reinforcement learning. And these are the types of machine learning that we use to train our AI models to recognize patterns and make decisions. Now, there are AI models that will also utilize neural networks. Neural networks are those computer models that are designed to kind of imitate the way the human brain works. We talked about a couple of different types of AI models that exist out there. The big two that we're going to be focusing on is Copilot and Gemini, but there are others. And I may demonstrate what some of those are in some shorter videos after this one. Now, some of the next steps that we have coming up, this is just AI 101. We still have AI 102, 103, 104, and then also our AI final. So be prepared for us to go a little bit deeper into some of these different topics as we go along. AI 102, we're going to focus on prompt engineering. AI 103, we're going to focus on Copilot and Gemini specifically. And in AI 104, we're going to focus on how to use AI to enhance our job searching. Thanks so much for watching, and I'll see you in the next video.